For this video, we are going to be looking at 1.5 investments involving regular payments, and we're going to be focusing on different types of examples. So for the very first example, we have Adam made $200 payments at the end of each year into an investment that earned 5% compounded annually. Blake made a single investment of 5% compounded annually. At the end of 5 years, their future values were equal. So what was their future value? So we're going to focus on Adam because we got all the information we need for Adam. Okay, and so I already have my investment calculator up, and make sure that the right side is zeros and nos. And so Adam's making $200 payments, so starting amount is zero because he doesn't have anything in his account to start with. Then he's going to make a $200 payment. It's at the end of each year, and this is going to go for 5 years. So it's once a year for 5 years. So our number of cash flows is 5. Our interest rate is 5. And that's our future value is the unknown. That's what we're looking for. It's compounded annually. So I need to have my start date for the first of the month, and then my first cash flow is going to be a year later, so 09/01/2022, and this is compounded annually. And I just calculate, and so the future value for these, for both of them, is going to be $1,105.13. Okay, and so now we want to know what principal amount Blake invested 5 years ago. So Blake is doing one lump sum right at the beginning and got to the same amount as Adam did. So what I'm going to do is I'm going to leave the goal amount, the future value, to the $1,105.13, because that's what they both ended up with. It is still 5% for 5 years, but Blake is not making regular payments, so that's going to be 0. And the amount he started with is going to be the unknown. Dates stay the same. Go hit calculate. And so the amount Blake invested at the beginning, so his principal at the beginning of the 5 years, would be $865.90. So we want to know who earned more interest. So to start with, I'm going to look at Adam. So for Adam, I need to know how much he actually paid into this. So he was paying $200 at the end of each year for 5 years. So I'm going to take the 200 and times it by 5. And so that works out to be $1,000 that he paid. And so now I'm going to take my future value minus the amount I put in, or amount Adam put in, and that'll tell me how much interest he had. So the future value was $1,105.13 minus the $1,000 he put in. So the extra money he gained was $105.13. As for Blake, he got to the same amount, so his future value was the $1,105.13. I'm going to minus the amount of money he started with, the principal, so it's $865.90. And what is left over is the amount of interest he gained. So we have $1,105.13 minus $865.90. And so we're left with $239.23. So Blake is the one that ended up earning more interest. So we have Blake earned more interest. And the reasoning for that is because he was able to put all that money in right at the beginning. So he had more money earning interest for a longer period of time. So he had more money earning more interest over a longer period of time. Okay, that finishes example 1, so let's move on to example 2. So for example, we have Jeremiah deposits $750 in an investment account at the end of every 3 months. Interest is compounded quarterly, the term is 3 years, and the future value is $10,059.07. What annual rate of interest does Jeremiah investment earn? So I'm going to go to my financial calculator. So he doesn't start with anything, but he's making $750 deposits, so that's my periodic investment amount. And my starting amount is going to be 0. And he's doing it every 3 months. And so if he does it every 3 months, that's 4 times in a year for 3 years. So his number of cash flows would be 12 then, because 3 times 4 is 12. In this case, the unknown is what our interest rate is, but it tells us what the future value is. So that's the $10,059.07. And so we're compounded quarterly. So I'm going to switch my drop-down menus to quarterly. And for my dates, I have to go 3 months later. So 3 months later would be December, so 12/01/2021. Hit calculate. And so oh, I did not type in the goal amount properly, so let me fix that. So I missed a 0. So just a point, make sure you're double checking what you're putting in. So let's try this again. There we go. Now we got it this time. So this investment is going to have an interest rate of 8%. So the interest rate was 8%. And that question's done. Okay, moving on to example 3. Celia wants to have $300,000 in 20 years so that she can retire. Celia has found a trust account that earns a fixed rate of 10.8% compounded annually. So what regular payments must Cecilia make at the end of each year? So for this one, we're doing regular payments, so the starting amount is going to be 0. The periodic investments are the regular payments. We don't know, that's what she's trying to figure out. We're doing this for 20 years, and it's compounded annually, so once a year for 20 years. So 20 times 1 would be 20, so the number of cash flows is 20. The interest rate is 10.8%. The future value we're trying to get is the 300,000. Oop, 1 too many zeros this time. Now today's date is where it's supposed to be on the 1st, but we need to do annually, so this needs to be a year later. So 09/01/2022. Our compounding is annually, so my drop-down menus need to be annually. Hit calculate. And so her regular payment needs to be this $4,781.09. So regular payments equals $4,781.09. And so how much interest will she earn over 20 years? So to figure that out, we need to figure out how much money she's contributed. So her regular payment was this $4,781.09. We're going to multiply that by the number of payments she makes. So she's making this payment once a year for 20 years. So we're going to multiply that by 20. I'm going to bring out my calculator to do that. So we have $4,781.09 times 20. And so she is contributing $95,621.80. So now we're going to take the amount of money she ended up with, so the 300,000. We're going to minus the amount of money she put in, so the $95,621.80. And what's left over is going to be the amount of interest she's made. So we have 300,000 minus 95,621.80. And so we're left with $204,378.20. And example 3 is done. Okay, last example. So on Lewis's 20th birthday, he started to make a regular 1,000 payments into an investment account at the end of every 6 months. He wants to save for a down payment on a home. His investment earns 3.5% compounded semi-annually. At what age will he have more than $18,000? So for this one, I'm going to go to my financial calculator. Okay, so he's starting with nothing in his account, but he's making regular payments of 1,000. They are compounded semi-annually, so that's twice a year. And sorry, but this one we want to know how long this is going to take. So this is actually our unknown. His interest rate is 3.5. We are trying to get to 18,000. And so we're compounded semi-annually, so then it needs to be 6 months later. So 6 months later would be March. So 03, 01, 2022. We're doing semi-annually for these. And it says compounded semi-annually, so that's how I know what that is. And so I'm going to hit calculate. And under the number of cash flows, it works out to be 16. So just to know for this, to do years, so the cash flows works out to be 16, but we're doing this semi-annually or every 6 months. So what that means is this cash flow is happening twice a year. So what I'm going to do is I'm going to take that 16, divide it by the 2 for the twice a year, the semi-annually part, and it works out to be 8. So it is 8 years that it's going to take him to go from nothing to $18,000. And that ends example 4. So quick summary, the future value of a single deposit has a greater future value than a series of regular payments of the same total amount, and small deposits over a long term can have a greater future value than large deposits over a short term because there is more time for compound interest to be earned.